Hello everybody, here we are, and just a minute, my mouse is not working. What's the reason? For some reason it doesn't work. Okay, never mind, let's go ahead. So here we are gonna be mainly discussing about this, but first of all, let me fix this here. Why is my mouse not working? Okay, finally it started working. And by the way, in this particular live, I'm mainly gonna be discussing about the ECS part that was remaining yesterday. So few things got left and they were remaining, so we are gonna be focusing on that. And apart from this particular thing, then we will talk about the Kubernetes, because that's something I have to simply go through. Hopefully by 7 o'clock or something it's gonna be done. Then I will be learning more things about Kubernetes. It needs to be done as soon as possible. But before that, let's simply get it done. And once it's done, that's it. No need to worry about anything. And let me turn it off. So this is done. Apart from this particular thing, let me turn off this. So almost everything is done. I hope everything's clear. Yes or no? Let me know. Yeah, I think everything is done, but at the end of the day, maybe the sound is less on my side, if I'm not wrong. Coming back to this, let me spin up barrier. Here it is. And what we are gonna be doing today, that's gonna be something interesting. How about recreating the project, just a basic project, and then getting the things done there. That will actually be a better thing. In this way, I will get the chance of writing the CI/CD pipeline, and not CI/CD pipeline actually, writing the Docker file, and that would be actually great. So just a minute, let me spin up it on my side. I'm gonna be recreating a basic project again, and over there I will be just simply configuring the things. Just a minute. The IP address ends with 10. Okay, the IP address has changed completely. That's insane. So 10.98 point this point this. Let's simply start it, and hopefully if I start here, okay, now it's working fine. And okay, what do I need to do first? First of all, I'm gonna be recreating a project, everything from scratch. This time it's gonna be quite quick. It will not be taking a lot of time. So we have gone with ECR, EC2, ECS app. Even we created yesterday. So let's simply create ECS folder here, and inside ECS folder I will have all these things here, and learn my app. What does it have? Don't really know. To do and all. Okay, let's do one thing. Just here, I'm gonna be creating one more just for testing purpose right now. Or let me do one thing. What should I name this app? Test app. This is gonna be test app, or let's name it node app. So this is gonna be node app, and over here I'm gonna be just simply initializing everything. The thing is that we will be re-going through all the steps so that we are sure that we know. That's it. This is the main region. npm init. It's gonna be quite sorry, I want to make it quick, but not like this actually. Just like this. So this is the, let me open it here and make it a module. Apart from this particular thing, few commands need to be here. First one is gonna be the build command. Okay, when it comes to the build command, so that command will be tsc only, just like this. And then I'm gonna have a start command that will be starting it. So /list/index.js, just like this. Apart from this particular thing, I will have dev command, and npm run build and npm run start. It's gonna be pretty simple. I will not be focusing on the unnecessary things too much. It's gonna be quite simple, just like this. And apart from this particular thing, just here I will have source. That's crazy, that's bad. src, just inside src I'm gonna be having index.html file, and then index.html file, crazy. npm install express, and npm install @express or @types/express as the dependency. Let it install. I will have index dot ts here. Once I have this, I'm gonna be importing everything. So import express from express const app. That's gonna be express here, and apart from this particular thing, const port is gonna be, let's keep it 3000 for now, it doesn't really matter. App dot listen, I'm gonna be keeping it really simple. It will be listening on the port, and clg server is running on port and port, just like this. So this particular thing is done. Apart from this particular thing, I'm gonna be having few routes here. First one is gonna be get slash route, and that's gonna be response dot, I need to have it response request response. Coming back to this, response dot send, and the route. Then I will have health check, so app dot get slash health response dot send. Okay, never mind, response, and request response. Apart from this particular thing, response dot send up and running, just like this. Apart from this particular thing, app dot user, app dot get slash host name. The question is, how will I get the host name? Again, request response, and response dot send. I'm gonna be sending the host name from here, and host name should be os dot of course I need to import os first of all. So import os from os. I'm not sure whether this will work directly or not, but let's see, give it a try. Os dot host name, I think I need to call it here, just like this. And that was it that I was supposed to be doing. I will not be writing a lot of code, because it doesn't really make sense. We have to focus on the important part rather than focusing on everything at the same time. So this particular thing is done. Apart from this particular thing, npm install TypeScript as a dev dependency, and once it is installed, npm npx tsc init. So this is done. This is the file that I have here. I'm gonna be uncommenting these two, and that's it. Let me get rid of everything from here. What is the next thing that I will be doing here? The next thing that I will be doing here, that is inside this, everything is already running. Npm run build, let's run this command. That's already built. Npm run dev. So first of all, it will be build. Then I'm getting the permission denied dist index.js. That's okay. So the permission got denied here. So let's keep it like this. Npm run dev. Interesting. So the permission got denied. So slash dist index.js, dist index.js not found. So first of all, it is saying that is not found. So let's keep it like this. Permission denied. So don't I have this here? Index.js, I do have it, and I have all the code here. Interesting. Let me get rid of this. Index.js, app.listen, I'm listening on the port, and what's the right way to write the name here? So coming back to this, slash, I think it will mainly say that permission file not found. Yeah, that's right. So even if it gets created but it is not found, that's problematic. In that case, if I write a dot here, that would sort of do the job. Okay, this is getting created, but ultimately permission denied for what? Why? If I run sudo and ultimately npm run start, won't it run? Permission denied. Sudo. npm run dev. It's going to be started now. It is running on 3000 port. If I go to 3000 port right now, first of all, how to access camera. Let me copy this path. This one mainly. Let me paste it here and let me disable it now. Launch it. Alrighty, this thing is done. Close this as well. Coming back to this one, I have to go to localhost and 3000. If I go here, I am on the root. Let me turn on the dark mode. What's wrong? On. And then we have health up and running, and then I have host name Ubuntu. So yeah, it's working fine. What is the next thing that I can do? The next thing that I can do here, stopping everything, time to build the image. As simple as that. Docker file. For building the Docker file, from node 24 as builder, I will have many stages here. This is the first stage. I will be creating a work dir, and that work dir can be anything. For now I'm gonna be making it build, just like this. And once I have the work dir, then I have to copy the stuff to in the work dir. So package everything.json should be copied to the work dir. And apart from this particular thing, once I have copied this, after that copy source to source, just like this, ultimately source and everything. So I'm gonna be copying source to source, and even before that, once that is copied, I will be copying or first of all, once the package.json I have here, let me run npm install, just like this. So once I got package.json, I'm gonna be installing everything. Once I've installed everything, then I'm gonna be copying the source. Copy what? I'm gonna be copying ts config.json in the current directory. So this thing is also done. Once that is done, then I'm gonna be running npm run build, and that is it. This is how it's gonna be going on. So first of all, I got it from I got node here as builder. That's fine. Work dir/build, copying the package.json file from here, and running npm install. Once after that, copied from everything from source, and then ts config copied. And once that is done, then what will I do? From base image. What is the base image over here? The base image is builder here as runner. This is gonna be the base image. And what will I do now? This can be anything, right? This is the builder, this is the runner. That doesn't really matter. I will create a work dir. The work dir is gonna be /app, and apart from this particular thing, I'm gonna be copying some of the steps. So first of all, I will copy from a stage, and that stage is builder. I'm not gonna be describing, like talking much about them, because yesterday I talked about them a lot. And node modules, I'm gonna be getting everything in node modules only. Okay, this particular thing is done. Copy from builder and node. Actually, this should be build / even I need to write build here at the top. This should not be node, this should actually be build, because the image name is build. So build / I want to get package everything.json in the current directory. The spelling is wrong, so let's name it package. And lastly, copy from builder and node, actually build / src, not src, actually dist. I'm gonna be getting everything inside dist, just like this. So this way I'm getting all the files. Once I have all the files, then I will run or just a command. That should be enough, and the command is gonna be that is it. So ultimately here what all I have the app. That's great. Inside the app I have all the node modules. I have the package.json, I have the dist, and then I'm just simply running it. That would do the job. So overall this should be fine. This is stage number 2, and this is the stage number 1. I wrote it yesterday, I wrote it again today, so that I'm sure about the things. And apart from this particular thing, I will have one more dot docker ignore here. What all should be ignored? So by default node modules should be ignored, then dist should be ignored, then docker file itself should be ignored. So let's close this. And if I want to build the image, npm run, not really, docker process status, permission denied. Let me spin up docker here. Well, docker is already here, so let me click on that. By the way, I haven't set it to starting app. It should be started as soon as okay, never mind whether it does or not, hardly matters. So what will I do? I have my node app, so docker process status, that's running. So docker build tag is gonna be node app, and node app, apart from this particular thing, from the current directory, it will be just simply building everything. So let's wait for a while. It's not kind of a big one, so it should be quite quick. So hopefully image is going to be built. Okay, from first of all there is a problem. This as should be in capital letters, just like this. Let me try to build it again. Okay, this has been built. Now if I see docker images, so I will have that image over here. So docker images, come on, the image should be somewhere here. Node app, this is the image that I have. And once I have the image, so I'm gonna be pushing the image to, first of all, yesterday I pushed the image to ECR, Elastic Container Registry. Today I will be pushing this image to the Docker Hub, and then from there I will be using this. But before even that, there is one thing that is remaining. That is first of all, building the image for the Docker Hub. Apart from this particular thing, let me do one thing here. Just in here, I will create a docker compose.l. Pretty simple. I will be running some of the services. First service is gonna be node app, and inside that, first of all, I'm gonna be building. When I'm actually building, I'm gonna be building everything using current directory. As for the ports, they are gonna be 3000 by 3000. What will happen? It will automatically build, and it will automatically run the service. That's great. So if I say docker process status, nothing is running. Docker compose up, it will just simply start that. So it will first of all build that, then it will start that, and ultimately it is up and running right now. So in the detached mode I will be running it. If I go to 3000 port, it will still be working. This is the name of the container that is just simply running it. Okay, so that should be fine. It is running inside the container, and this is the host name of that particular container. So that does the job. What is the next thing? Nothing. Simply run docker compose down. So it will just simply stop running that, and once it is stopped running, so doesn't matter how hard you try, you will not get the result over here unless you start running that again. So this much we have done. What is the next thing? Let's simply exit it from here. Now the next thing is that I have to push the image to Docker Hub, and for that, Docker images. So this is the image that I want to push to the Docker Hub. So first, before even that, I need to set a tag to this particular image. So Docker set images, Docker set help, yeah. I want to set the tag. Yeah. So create a tag, this is source image. So Docker set a tag. I want to set the tag. To what I want to set the tag? I want to set the help again. So once I'm using this tag option here, not really getting something helpful here. So docker set tag to node app latest. We want to set the tag to this one. What should be the tag? The tag should be unstoppable. Ultimately my name should be prepended. So unstoppable the coder, my username of docker hub I mean slash node and app dot latest, sorry, colon latest. If I do this, nothing, it did not work. That's okay. So I'm gonna be doing one thing. Maybe I don't know the commands. That's really not a big problem. We can know it later. Docker build. I'm gonna be building it again. The tag is gonna be unstoppable the coder docker images. So docker build tag is gonna be unstoppable the coder slash node app and latest in the current directory. So it will be built. So once this is done, once we have built this, we will be directly pushing it. So docker login, you need to make sure that you are logged in. In my case I'm logged in. In your case you may have to log in before you are actually able to push. So docker push and unstoppable the coder we are going to be pushing this node app latest. We are going to be pushing it to the docker hub. So it's mainly going to be pushed to docker hub quite fast, and didn't really expect it to be this much fast. So this thing is done. Apart from this particular thing, what else can I do? Once it is pushed to the docker hub, by the way, it's still pushing, few MBs are remaining and all, and by the way it is about to be done. So let me open docker hub. So here hub.docker.com. It's gonna be quite quick. We won't be wasting any time at all. This is the node app that we've got here. That's interesting, and that simply means it has been pushed. That's right. So ls, let's not worry about anything. What is the next thing? This thing is done, right? That has been pushed to there. And the next thing is that we have to go to Amazon. The good thing is that we are already here, and inside this I'm gonna be going to the ECS, Amazon Elastic Container Service. That is mainly used for running the containers and all. So let's go. I'm not gonna be going to the registry because it is mainly used for pushing the things and all. I'm simply gonna be going to the service. Yesterday we talked about registry as well quite in detail. Today I wanted to use Docker directly here. And again, I will not talk about how the things work over here. Yesterday in the live, I actually discussed everything in detail. So node app cluster, let's simply name this. Once it is named, forget only, and let's simply create it. Gonna be quite quick, as I said. The main goal is gonna be on getting the things done as soon as possible. Let's create a new task definition. What is task definition? Why do we create this? Have discussed it in detail. Node app task definition, just like this. Apart from this particular thing, this is done. Okay. Whatever. Okay, name. First of all, container name. What should be the container name? So node app. Let's name it container. That doesn't really matter. So this is gonna be the node app container. As this is the specify the container image, whether blah 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 container. Ultimately, this is gonna be the node app. Call it node app container. Up to you. Let me call it node app container. What should be the node app? Ultimately, it's gonna be node app only. But if I'm making it node app container, that is fine as well, because at the end of the day that's gonna be container only. Second thing is that I need to have the repository name. So let me go to here and repository URL. Let me click on this. How will I get the repository URL? And I think this is the public tag. The question is, this is the repository URL if I'm not wrong. I think I should be getting it. Let's see if we face some errors and all. But repository URI then image tag. Repository URI plus image tag. It's not like I can just directly provide it and it will work. So repository URI plus image tag. So when it comes to repository URI, public view, I'm not sure that I need to provide this URL or directly image name. Let me provide the image name directly. Hopefully it will work. If it doesn't work, then so ultimately I will be just simply changing it if it doesn't work. Browse this here, and then this. Okay, port number 80. This is gonna be what? Port mappings. The container should be running on port 3000 ACP. Container port, you can just have anything, or you can just even don't specify it. So whether you specify the name or not doesn't really matter. And we have health route. When it comes to health route, let me just have it here. The health route is first of all, it is on port 3000, and health, this is the route for that. So once this is done, internal timeout, we don't really need to worry about anything because they are set by default, so it's no use doing anything here. And storage monitor, let's simply click on create, and let's see what happens. So the task has been created. One thing may be problematic here, that I may have to update the task. Updating the task in the sense action. Right now I'm using this directly. What is the image here? Task placement, versions, attributes. I may have to change the URL of the image, but let's see what's gonna be happening. Hopefully that will work directly. And node app cluster, let me click on this. Let me create a service. Service will be selecting the task definition. Once the task definition is selected, service name, task definition, service. Let me just simply get rid of this thing. That's it. Apart from this particular thing, forget 0 latest, no need. I need to have two tasks. Health grade, let's simply get rid of everything. Networking, service deployable, load balancing, let's simply work on this as well, and it will be running on this. That's fine. Creating a new container, load balancer. So node app load balancer, just like this. Once this is done, it will be listening on port 80. This target group name node app target group. Again, it will also be listening on port 80. This thing is done. And service auto scaling, let's add a few things here. First of all, minimum should be 2, maximum can be 10. Again, that I'm talking about the number of the tasks. Policy name can be node app policy, not polity, just policy. ECS gonna be on the basis of CPU utilization. It should be 70 by default, so let's not worry about that, and let's simply click on create. That is it. Whatever I had to do, I've already done. Now I have to see when the cluster is going to be created, and as soon as cluster is created, is this actually able to run the image that I have specified or not. So that's it. You gotta wait for a while, and meanwhile let me start discussing about Kubernetes. Yesterday I discussed about this a lot. Whatever process I have followed right now, I discussed about each and everything yesterday. So that is why I'm not gonna be I haven't discussed that again today, because of course we don't really have a lot of time, and we are short by time first of all. And the another thing, we have to talk about Kubernetes, the basic stuff at least. That's the main reason. By the way, I will be talking about it a lot. Once if it runs great, then that's great. We will be talking about that. If it doesn't run, then can't really do anything. I'll have to fix. What else? So you will have to wait. Meanwhile, I'm just opening a Chrome on my laptop right now, so that I can just simply discuss about this stuff. The thing is that this is the first time that I started learning about Kubernetes. I have known about the basic stuff and all, so I'm gonna be talking about them. And once I have explained each and everything, even I will do few things in action. So we will be going through that. And once we have gone through all those things, after that I will start learning more things on that, as simple as that. So let me refresh it. The service hasn't been created yet. Coming back to this Kubernetes and ECS. Okay, so what is ECS? ECS full form is Elastic Compute elastic compute container service. And what it does, this is a service that is specifically has been created for containers. So if you are running something inside the container, now you need to scale up, scale down, you have to manage the containers, you have to update that, you have to create a new one. So in that case, this particular ECS service is used. The thing is that this ECS service is based on AWS. That simply means you will be restricted to use AWS only. So if you know ECS, that's great, but you are restricted to use only Amazon. You cannot use other services like DigitalOcean and all. And that's the benefit of learning Kubernetes. The Kubernetes, they give you some more options as well at the end, but they sort of do the same thing. Kubernetes just simply manage the containers and all, update the container, delete the container, create a new container, okay, auto scale, down scale, all these things are handled by Kubernetes as well. And the only difference is that Kubernetes can be used with any service provider, be it AWS, be it DigitalOcean, be it any another service provider. So it's gonna be working with all of them. And AWS ECS is mainly dependent on the AWS. So this is the main thing. Coming back to this one, 2 pending, that simply means it started working. Such a good thing that that is, we have containers running. That simply means we did not make any mistake at all. And we allowed the request on HTTPS. Load balancer has also been created. Even we have the target group. That simply means if we send a request to the load balancer, we are gonna be getting the result. But first of all, let's wait for a while and let's see whether I'm actually gonna be getting the result here or not. So we have talked about ECS quite a lot. That's really good, interesting stuff. Like on top of we have ECS service, inside ECS service we have clusters, and I mean just below that we have services, and services they use task definitions to just simply create the tasks. So this is the only thing, and ultimately tasks run there. What else? So I hope it does make sense. But the thing is that how long will it take? Whew. Okay, they are running right now. So if I go to my load balancer, the question is how will I get the load balancer and where will I get it from? To get the load balancer, you actually need to go to inside EC2. You will get something called load balancers here, and the load balancer that you created you will get here. From the load balancer you have to get the DNS name. And what is the DNS name here? This is the DNS name. You have to just simply make a request to this DNS name, and the request goes. This is gonna be the request to the wow, we are getting the result. But first of all, let me fix this. So for fixing this, how to access camera in HTTP request. How to access camera in HTTP Chrome without that. I have to disable it actually, so copy it, paste it. Let me disable it. Relaunch. Okay, this is gonna be relaunched. Let's simply click Control W. Coming back to this, I'm getting the result. That's great. And apart from this particular thing, if I go to /hostname, so this is the host name, IP, whatever you call that. If I reload it, it changes. If you actually have a look, it keeps changing. First of all 32.175, then 21.137, again 30. So because we have 2 containers running, so sometimes request goes to the first container, then the request goes to the second container, and this way different containers are handling the request that I'm sending. So this is how it just simply goes. Such a good thing, and we have covered this. Okay, so again, if you want to know more about exactly what I've done here and all, you can just watch yesterday's video, or you can watch even better videos on. Even I covered actually the things the best way possible. So if you feel like going through, just go through yesterday's video, which was like on 11 or something. Coming back to this one, let me discuss it briefly, and then I'm gonna be talking about Kubernetes here. So untitled. So we mainly discussed about this. So what exactly happens? We created the app. Okay, just right now what we did, we created the app. We then built the image using that. We even ran the image locally. After that, yesterday we pushed the image to the ECR. Today we did not, because of course we don't have time. And and as we did it yesterday, so what is the use of doing it today? And then we pushed the image to Docker Hub. Today we did that, and then we created ECS service. This is the most important part, that is mainly responsible for managing the containers and all. And that is it. What happens inside ECS? Inside ECS we have clusters. That's right, we created the cluster first of all. Then inside clusters we have services, And services need a task definition, so we need create a task definition. Task definition in the sense definition about the task, information about the task. So services, they use the task definitions and they are responsible for running the tasks and all. And lastly, we created the load balancer. So and then ultimately whenever I send any request, the request will go to the load balancer. Load balancer will forward the request to the target group. Target group will decide which task to use, whether this needs to be used or this needs to be used. So this is how it just simply goes on. Alrighty, so this is all that we have discussed. Let's continue from here on. Let's delete everything and let's talk about Kubernetes. Kubernetes, and now what is the how to pronounce this? How to pronounce, because I've been pronouncing it for a while, and if that is a wrong pronunciation, then that's gonna be crazy. Kubernetes.
Kubernetes.
Kubernetes. Kubernetes. Okay, that's fine. I mean, I've been pronouncing it quite the right way.
Kubernetes.
Kubernetes. Kubernetes.
Kubernetes.
Kubernetes. It's better to call it Kubernetes, but okay, I've been pronouncing it right. That's the thing that matters the most. Okay, then coming back to this one, what is Kubernetes? Just like ECS, we have Kubernetes. ECS is dependent on what? ECS is dependent on AWS. So when it comes to ECS service, Elastic Container Service, it is dependent on AWS. But when it comes to Kubernetes, it is not dependent. Kubernetes. It is not dependent on anything at all. You can use it with anything. But again, if you want to use this, you will have to learn about that and all. Okay, and when it comes to Kubernetes, so let me start discussing about the things one by one. So the first thing that I'm going to be talking about here, again I'm going to be writing the code and all. Clusters. Again, the way you have clusters here in ECS, the same way you will have the cluster in Kubernetes as well. So kind of overall it's going to be fine. So let's simply start going through the theory. So what is Kubernetes? Docker is a pre-built, okay, of course you need to know about Docker. If you don't know, then it's gonna be hard. Kubernetes, popularly known as K8s. Ultimately, Kubernetes, there are 8 characters. So if you actually calculate this, so 1, 2, 3, 4, 5, 6, 7, 8. So K 8 characters S. That is why it is called K8s. K8s, just like this. Nothing else. So Kubernetes, popularly known as K8s, is a container orchestration engine, which, as the name suggests, lets you create, delete, update containers, and that simply thing. It just does the same thing. And it is the container orchestration engine. Orchestration in the sense which manages a lot of things and all at the same time. This is useful when you have your Docker images in the Docker registry and want to deploy it in a cloud native fashion. You want to not worry about patching crashes. You want the system to auto heal. The thing is that even here, as we have deployed this here, so if some containers, we have deployed the container image on this AWS, right? AWS ECS. So if for some reason a container crashes, a new container will be spawned automatically. So this is what actually happens here. Coming back to next one, you want to auto scale with some simple constructs. This will auto scale as well. So whenever the load goes over 70%, this particular service that we have created, it will auto scale the containers. That simply means it will create some new containers. And then you want to observe a complete system in a simple dashboard. That's okay, fine. Let's continue from this one. So ultimately we have many machines, and the thing is that in Kubernetes, because right now I'm mainly gonna be talking about Kubernetes over here. So in Kubernetes we have a top level cluster. So what I mean, the way we had a cluster here, let me go few steps back. So if I actually show you, so that I can just simply compare both the things. Okay, so this was the diagram that I created for Kubernetes, sorry, ECS. Let me get rid of this for now. But this is the overall diagram that I created for it, right? So what happens here, this is the service name, and inside this service name, first of all, we have top level cluster. Similarly, even here in Kubernetes, gonna be talking about Kubernetes here, we will have a top level cluster. Again, we will have to create all these things on our own, the way we did here, the same way we will have to do it in Kubernetes as well. So in Kubernetes, what happens, we have top level cluster. Let me give the color to this. So this particular thing is done, and apart from this particular thing, and inside this we will have many machines. So there can be one machine, there's gonna be another machine, So this way I'm gonna be having many machines. And when it comes to these machines, so they are actually called node. So node, this is all the machines, they are just simply called nodes. So let me change the color, that should be green, and copy, paste and paste. So at the end of the day they are called nodes. That's done. You can call it machine number 1, machine number 2, machine number 3 and all, but ultimately they are nothing but nodes. Okay, and inside those nodes, they are nodes, and apart from this particular thing, inside those nodes there is something called pod. So in each node there is a pod. Okay, what is the pod? So in the nodes there is pod. So inside the, and pod is responsible for running the containers. So this is how it just simply goes. So when it comes to pod, so what is a pod? First of all, pod is kind of a service, kind of service responsible for running the containers. So over we have service, and we create the task definition. Service simply runs the tasks. In Kubernetes we have top level cluster, so this is nothing but the cluster. So this is the top level cluster we have. Inside that we have proper nodes, and in each node we have something called pod. We can have one pod, we can have multiple pod as well. And what do pods do? Pods are simply responsible for running the containers. So they are simply responsible for running the containers. Then can be one container, then can be multiple container. Okay, usually there are like one container only, but you can have multiple containers as well. So pods are mainly responsible for running the containers, and you already know what is a container. Container is just a like Docker container, and that will run your image, as simple as that. So I hope it is pretty simple. Kubernetes clusters, Kubernetes clusters, Amazon machine, we have already gone through them, and inside those containers you may be running anything. You may be running front end, you may be running back end, you may be running both. It's completely up to you. Okay, so this particular thing is done. Then there are few things. Earlier, what we have been doing so far. I mean, if we are deploying something, if we are deploying directly, so we were deploying on EC2 machine, right? So on the EC2 machine we directly deployed, then using the load balancer and target groups, using R2 scaling and all, we got this stuff done. Ultimately so far we've been doing the same thing. Right now what we will do from this time onwards, we will build the image, we will create a server, and we will build the image of that particular server. So instead of directly deploying that, we will deploy that using a container. So we will just build the image, and at that time you can use something called ECS, and it's completely up to you which service you use. But yeah, ECS also one of the services, and mainly Kubernetes does the same job. Okay, I hope it is clear. I'm not gonna be like discussing the things quite in detail, because of course don't really have time. But hopefully you are getting that. If you are getting that, that's great. If you are not getting that, you will have to learn the things from scratch. Then it's gonna be overwhelming initially. Coming back to this one, the next gonna be okay for front end EC2 machine ECS. Okay, that's fine. Front end React, we will even there is something called CDN. So what CDN does, that if you have static files, you can directly upload those static files in CDN, and you can just simply access it using CloudFront. What is a CDN? I mean, CloudFront gives you the service of CDN, and what happens that on S3 storage you just simply upload. Suppose you have static HTML files, so or JS or CS files, you will upload it there, and then using CDN, using CloudFront, you will just simply get the access of them. Having said that, you can directly get the access of the things uploaded on S3 storage on AWS, but using CDN it is preferable, because it adds extra security that you cannot access your images directly. Rather, CDN will be able to access them. Make a request to the CDN, CDN will give you. It's just like that. I mean CloudFront time. Make a request to the CloudFront. Okay, so this particular thing is also done. Your front end backend are all pods in your Kubernetes cluster. So your front end backend are all pods in your Kubernetes cluster. So ultimately what I mean here, that there are many nodes inside the machine. Inside those nodes there are pods, and those pods are responsible for running the containers. So this is how it just simply goes. So when it comes to your front end or the back end, they are running inside the container. Pod is responsible for running the container. So if there is a container that runs your front end, and pod is running the container, so ultimately that's nothing but the pod. Okay, then simply said, there are gonna be many machines, and one more thing, there are gonna be many nodes, and among those nodes there's gonna be a master node as well. So just like this, so there's gonna be like workers. So ultimately everything is node here, but if I try to name them, give them proper names, so this is gonna be there's gonna be one master node, and others worker nodes. Again, what is a master node, what is a worker node? It's pretty simple, right? Master node, others are gonna be workers, just like this. So master node is the main node, so mainly most of the time the request is gonna be coming here, and when the request comes here, this is responsible for running the workers, so it will just make sure that workers are gonna be running and all. And I hope this does make sense. I'm gonna be talking more about it, don't worry. And AWS developer, I'm just simply going through it and then talking about the things on the go. This is actually what I'm doing right now. So apart from this particular thing, there are few jargons that we need to know. So there is a let me just simply go through this. There is a blog. It's better to just simply go through that and talk about the things. So this is what I've been discussing so far, that in Kubernetes, first of all, you have the top level cluster. Apart from the top level cluster, you have many nodes. So this is the node, this is a node, this is a node, and inside there are three things mainly. This is the master node, and they are the workers nodes and all. Ultimately call them master node, or just simply call them control plane. So just, it is not control panel, it is control plane. So you have main node, main machine inside a cluster that is mainly responsible for running the nodes, and inside those nodes you have some other things. So inside control plane you have the API. So what actually happens, that inside control plane, we call it master as well, there is something called API. So you can even have a look at it better. API in the sense API server. So we have API server here. CM stand for control manager, so we have a control manager. And then CCM stands for control cloud manager, cloud control manager. So we have API server, we have control manager, we have cloud control manager, we have etcd, that is mainly for the persistent store. So you can just simply read more about it. And then that is it. These are we have schedulers as well. So these schedulers are mainly responsible for scheduling the nodes, tasks and all. So this is done. So ultimately you have many nodes. So what I meant over here, you have many nodes. Among those nodes there is a master node, and others are workers. Master node is called control plane. Others are gonna be called nodes, or just workers, you can call them. Coming back to this one, when it comes to control plane or master one, it has API server, it has control manager, it has cloud control manager, it has etcd, that is the storage, it has schedulers that are used for scheduling the stuff and all, scheduling the tasks and all. And then whenever you make a request, the request will go to the cloud control manager. So from cloud API provider, the request will go to the cloud control manager. Cloud control manager will send the request to the API server. API server uses control manager to just simply run the tasks and all. And we will be even going through the definitions of these. And then inside these we have nodes, and nodes have kubelet and kproxy. What are the kubelets? Kproxy is mainly used for connecting the things together. So like even the nodes that you have, there's gonna be internal network among them. They are gonna be connected to each other using kproxy and all. We will be just simply discussing about these things. So inside this you have kubelet and kproxy. What is a kubelet? Kubelet is mainly responsible for creating I forgot. Don't worry, I will talk about that. By the way, the boxes in this blue color, they are nodes. So we have gone through that. The box in this white color, that is the control plane. So we have control plane, we call it manager. Manager. Is this a manager? Sorry, master, not manager. And then we have nodes, that you can call them workers. We have schedulers inside control plane. We have kproxy inside. We have kproxy or kproxy, call them anything. So inside node you have a kproxy, simply stands for kproxy, and you have a kubelet, you have etc, and all these things. You had better know the full form, as well as have a little idea exactly what they do. Let's talk about the things from here. The components of Kubernetes clusters. Core components. A Kubernetes clusters consist of control plane and one or more worker nodes. So what I said, there is a master, call it master or call it control plane, and then there can be one or more worker nodes. So call them nodes, and more specifically they are worker nodes. Here's a brief overview of the main components. Let's simply go through them. So control plane components. So we have two things over here mainly, if you have a look at this. So we have control plane in white color, we have nodes, they are specifically workers in blue color and all, sort of blue color, not quite blue one, but okay, blue sky, right? So let's talk about control plane. Inside control plane, we have API server, we have control manager, we have cloud control manager, we have etcd mainly for storage, and we have schedulers. So let's see exactly what they do. Coming back to this one, manage overall state of the cluster. Kube API server. So this is the middle one that we are talking about. That is the Kube API server, the core component server that exposes the Kubernetes HTTP API. What happens? Kubernetes HTTP API. There are gonna be many nodes, there are gonna be many services running, but unless you expose them, you will not be able to talk, others will not be able to send a request. So this API server is mainly responsible for exposing it. So there are going to be multiple node workers, but at the end this control plane will have API server, and that will be responsible for exposing it to the HTTP APIs and all. etcd, what is this etcd? Consistent and highly available key value store for all server data. So it is a consistent and high available key value store. So inside this you have API, then you have etcd, so we are discussing about that. Continuing from here, then you have Kube schedulers. So we talked about API, we talked about etcd, we are talking about the schedulers over here. So what are the schedulers? Kube schedulers, to be precise, looks for pods not yet bound to a node and assigns each pod to a suitable node. So what happens? What I said, I told you from the beginning, there are many nodes. There is a master, you can call it control plane, and there are many nodes, and those nodes have what? Those nodes have pod. Pod is responsible for running the container. Containers ultimately run the front end or the back end, right? Any service you, for that sake. So what is mentioned over here? Kube schedulers looks for pods not yet bound to a node. So it looks for a pod, like, okay, is there any pod? Okay, not like this. Is there any pod that doesn't belong to any particular node? So it will just simply look for that. Is there any pod that doesn't belong to any node? And if that doesn't belong to any node, it will make sure that that belongs to a node. That is the main job of what? That is the main job of Kube schedulers. Looks for pods not yet bound to a node and assigns each pod to a suitable node. There can be possibility that one node may not be suitable for that particular node, so it will be reassigning that and all. So ultimately assigning job it does. Then Kube controller manager. There is something called Kube controller manager. Ultimately this is the thing that I'm talking about. We have API, we have schedulers. You already know what it does. It assigns the pods to a suitable node. This is nothing but the storage. This is the cloud control manager I'm talking about, and let's see what it does. So coming back to use of cloud control manager, even we have two things here. We have Kube control manager, we have cloud control manager. So when it comes to Kube control manager, runs controllers to implement Kubernetes API behavior. So it is runs the controllers which are responsible for managing the API, Kubernetes API behavior and all. And then we have cloud control manager, optional, integrates with underlying cloud providers and all. And that is it. We have talked about everything. Again, it's better to just simply see it in action, and when we see it in action, we just know more about all these things. But for now, what I'm gonna be doing, API server simply exposes everything, exposes all these nodes to the HTTP API. etc, this is the storage. Schedulers, they are responsible for assigning right pod to the right node. And then we have CCM, cloud control manager. This helps connect to a particular cloud provider. And then we have control manager, that is mainly used for running the controllers that just simply handle the API, Kubernetes API behavior and all, API stuff. Ultimately how the things are being managed and all, it just simply handles that. Okay, so at least we have some idea about all these things. If not, if we are not the masters, so at least we should not be newbie as well, like having no knowledge at all. Coming back to the next one, then we have node components, and inside node components we have a few things. Inside node components we have kubelet, we have kproxy. More importantly, we have pods, and the pods are responsible for running the containers. Inside that we have all these things. By the way, let's talk about that. So inside the node components, run on every node, maintaining running pods and providing the Kubernetes runtime environment. So ultimately what happens, node components, what does node component do? It maintains the pods. What are the pods? They're just simply running the containers and all, providing Kubernetes running in runtime environment. Inside that we have kubelet, kproxy, container runtime. These are the things. What is the kubelet? Ensures that pods are running including their containers. So what I said, pods are mainly responsible for running the container. They are gonna be inside node. Inside node we have kubelet. As simple as that. Again repeating. we have node. Inside node we have kubelet. Kubelet is responsible for running the container and the running the pod as well as the container, making sure that they are running and all. That's fine, great job. So ensures that pods are running including their containers as well. Kube proxy option maintains network rules on nodes, implement service. So ultimately what is the use of this? If I come back here, we have kubelet. So we have top level node, that is nothing but a worker. Inside that we have kubelet. Kubelets are responsible for running the pods, making sure that pods are running and making sure that containers inside those pods they are actually running. What is kube proxy? Kube proxy, of course, that is responsible for having the internal network among the nodes so that they can just simply talk to each other if needed. Okay, so this thing we've done. And container runtime software responsible for running containers. So there is something called container runtime inside nodes. So software responsible for running the containers. The thing is that if you want to run the container, so you should have some kind of container runtime, then only containers are going to be running. So you can just read more about container runtimes and etc. So this item links to third party project or product that is not part of Kubernetes itself. Your cluster may require additional software on each node. For example, you might also run systemd on Linux node to supervise local components. Add-ons extend the functionality of Kubernetes. A few important examples include DNS for a cluster-wise DNS resolution, WebUI for cluster management via web interface, container resources, resource monitoring for collecting the storing and container. I have no idea about these things. Just by theory, it's not really possible to just simply get everything. Having said that, I'm not gonna. I think I'll have to go. Let's see. Just a minute. Give me a second. So yeah, turns out I will have to go and join the meeting. So never mind. I'm gonna be catching up soon. Until then, take care. Bye bye. And we will be going through all these things. We will even just simply start everything from here. And then simply, by the way, the few things are remaining: container resource monitoring for collecting and storing container metrics, and lastly we have cluster level logging for saving container logs to central. By the way, these are the few things that I have no idea about. Ultimately, I haven't even like these are the add-ons and all. So yeah, we will be just simply going through them. Flexibility in architecture. Kubernetes allows for flexibility in how these components are deployed and managed. The architecture can be adapted to various needs from small development environment to large-scale production deployments. For more details information about each component and various ways to configure your cluster architecture, see the cluster architecture page. Okay, by the way, bye-bye, take care. I'm gonna be catching up soon. Soon in the sense just within half an hour. Until then, bye-bye.